In this video, I'll be showing you how to use the false position method to find the root of a function. And before we move on, I recommend that you copy this table down here, just so that it makes it easier when you want to input the values along the video. Or you can also download this Excel file, which I've shared in the description. And the Excel file is complete with all the workings already, but I still recommend that you follow through with this video to understand where we got those values from. So here we're given our problem, which is the function we want to find the root of, and we're given the false position method formula here, and here are our initial guesses. Now the initial guesses are still empty. And so an initial guess is basically our own hypothesis or estimate of where the root is. And so let's just take, for example, let's say we have our x lower and x upper guess is 6 and 7. What this means is that we're assuming that the root of this function here is anywhere between 6 and 7. So the root could be 6.1, it could be 6.2, 6.5, 6.9, and so on. But the thing is, in the false position method, we have to be a bit smart on how we choose our initial guesses. And so in this case, it's still incorrect. And the reason is because both of our evaluations are negative. Now, what are these f of xl and f of xu values? If we take a look at the formula here, it's simply just the evaluation of this function using the xl values, meaning 6 squared minus 15 times 6 plus 50. And the same thing for f of xu, which is just replacing all the x's here with 7. Now both values are red, meaning they're negative. But the thing is, in the false position method, we need one evaluation to be positive and one to be negative. So in this case, we have a negative value already with using 6. And so let's stick with that. But our evaluation with 7 is also negative. So let's try and make this positive. So what we can do is just simply move around these initial guesses. So let's try to make this 5. Okay, let's try to, it's still 0. Let's just go up. 6, 7 still negative, 8 still negative, 9 is negative, 10 is also negative. Oh, here, 10 is 0. Okay, so from this point forward, it should be that the evaluation should be positive. So let's try 12. Okay, 12 has given us a green evaluation or a positive evaluation. So in that case, we can start moving on with the iteration table. And so in the iteration table here, I've already linked all of the initial guesses here to our cell there. And I recommend you do this as well, just so that when we change the initial guesses, they also change in this table. Okay, so let's move on to f of xl. And f of xl is simply just evaluating this function here using the xl values. So it's simply just 6 squared minus 15 times 6, like this, plus 50. f of xu is the same thing, but in this case, we're evaluating with 12. So just Control C and Control V like this. Now, f of xr is where we implement the false position method formula. So it's simply just the following. Double bracket, xl multiplied by f of xu here, minus xu multiplied by f of xl here, the green cell. Okay, let's close bracket and let's divide this by the following. F of xu, they're a bit blocked by the formula here, as you can see. I'm still highlighting the cells, but just follow through. So f of xu is right here. Whoops, okay. F of xu divided, minus f of xl, which is right here, like this. Okay, press enter, and we get the following, 7.333. If this is a bit unclear, let me just put the formula for you here, like this, if you want to follow. Okay, for now, let's not input anything for the percent error, and let's move on to the second row of iterations. So in this case, we have to put in another value for xl. Now xl here is our xr value. So let's press equals and put in xr, like this. Now xu can either be two of these. It can either be 6 or 12. Now how do we determine that? In this case, let's just drag these formulas first. So highlight this and Control D, like this. And now let's figure out what we put in for our xu. Now again, like I mentioned previously, when we want to choose what xu is, we have to figure out if we've fulfilled this criteria of one positive and one negative evaluation. And so with our 7.333 XL, we've gotten a negative evaluation. So f of xu here has to be positive, meaning if we choose 6 here, okay, it's negative, right? So we cannot have this. So these two cannot be negative. Here, this cell here has to be positive. Since 6 gives us a negative, our only choice left is to use 12. And if we use 12 here, we get a positive 14. So we have a negative 6 and a positive 14. And so this is how we determine XU. Okay, now let's fill in our percent error. The percent error is simply just the absolute of the new root minus the old root divided by the old root, like this. Whoops. Okay. That was just a slide. Okay, no problem there. And let's make this a percent. Okay. Now, all the hard parts are done, and the rest is just easy. So we can just highlight all of this and copy the formula down here, like this. And we're basically done with the false position method. And so where is the root of the function here? Now the root of the function is in this column here, which in this case it's 10. Now how do we know that the root of the function is 10? Well, you can check for yourself using a calculator, but from this table we find out it's 10 once. We find out the root once. Here this column starts to become constant. So at the start, our first estimation of the root is still a bit jumpy. So it goes from 7.33 to 8.7 to 9 and so on. But eventually it reaches a point where it becomes very constant, right? So 9.999, 9.999, eventually where it reaches 10 and 10 remains constant. So this is how we know that we've reached the root of the function. Also, we can look at the percent error. As the percent error gets smaller and smaller, we know that we're getting closer to the root of that function. Now the thing is, this is a quadratic equation, and a quadratic equation has two roots, right? So this is the first root of the function. And how do we find the second root of the function? Well, we can do that by simply just changing the initial guesses right here. So since the first root lies in between 6 and 12, there's no way the second root is also there. So let's try using a initial guess which is smaller than these numbers. Let's change this to 2, and let's change this to 6. Again, you have to make sure that both of these values are one is positive and one is negative, which in this case we fulfilled. So we can use these initial guesses. And what we find using these initial guesses is the following. We found the second root of the function, which in this case is 5. And so the two roots of this function are 5 and 10. So that is simply the false position method for you. I have some other videos on different numerical methods, such as the fixed point, bisection, bracket method, Numerical, and so on. So if you're interested, please check them out. That is it for this video. Thank you for watching.